Welcome, geology enthusiasts, to the first episode of our Geology Dean mini-series on igneous rocks. Today, we're kicking things off by answering a fundamental question. What exactly are igneous rocks? Well, the word igneous comes from the Latin word for fire, which is a perfect clue. Igneous rocks are born from incredibly hot, molten material. Deep within the earth, this molten rock is called magma. When it erupts onto the surface, we call it lava. The story of every igneous rock begins with this fiery liquid. Now, imagine this molten material starting to cool down. As it loses heat, it begins to solidify, a process called crystallization. This is where things get really interesting, because where this cooling happens makes all the difference. When magma cools and crystallizes slowly, deep beneath the Earth's surface, it forms what we call intrusive igneous rocks. Think of rocks like granite. Because they cool slowly, the mineral crystals have plenty of time to grow large, often big enough to see with the naked eye. This slow cooling process creates a coarse-grained texture, giving us a beautiful mosaic of interlocking minerals. These intrusive rocks tell us a story about the hidden, slow-moving processes happening miles below our feet. But what happens when this molten rock reaches the surface? When lava erupts from a volcano, it cools very, very quickly in the open air or even underwater. This rapid cooling forms extrusive igneous rocks, like basalt or obsidian. Because the cooling is so fast, the mineral crystals don't have time to grow large. In fact, sometimes they cool so quickly that no crystals form at all, creating a volcanic glass like obsidian. The textures of extrusive rocks are typically fine-grained, a clue that tells geologists they formed in a fast-paced, high-energy surface environment. The size, shape, and arrangement of these crystals, what we call the rock's texture, are like a fingerprint, revealing the rock's cooling history. So, why are igneous rocks so important? They are the primary building blocks of our planet. They form the vast oceanic crust and the very foundations of our continents. By studying them, we can unlock the secrets of Earth's thermal history and understand the chemical evolution of our planet's interior. Every igneous rock is a time capsule, preserving a record of the intense heat and pressure from which it was born. They are the original rocks, the starting point for the rock cycle, and the very foundation of the world we live on. Thanks for joining me on this first step of our igneous rock journey. Stay curious, keep exploring, and be sure to subscribe for our next episode, where we'll dive deeper into the amazing variety of igneous rocks. See you next time.